Now we've finished solving for items that involve pattern recognition. Now let's start solving for those that include the change of variables. And the difference between pattern recognition and change of variables is that when we deal with items or integral that involve change of variables, we're actually writing its representative substitution. Meaning, for example, this certain function or inside function, you want to represent it formally in terms of u, then we would be rewriting the integral in the sense that it is represented using another variable. So to make it clearer, let's have this example. Now this can easily be solved because if you would be looking closely at our inside function, the derivative of 3x plus 2 would be positive 3dx. And in that way, the function can also be rewritten in by simple pattern recognition. But in this case, I'll be using the change of variables just to formally use this in this case. Okay, so una natin is check natin yung ating inside function. We have 3x plus 2, so that is u is equal to 3x plus 2. And then we take the derivative of u, and that is du, that is equal to 3 dx. Okay, and then we have to substitute these u du to the original equation. Gagawin natin ngayon is itong lahat ng mga x's dito, gagawin natin siyang in terms of u. So by doing that, we could say that dx from this expression, we know that dx is actually equal to du over 3. And if we rewrite this in terms of the integral, so that is the integral of the square root of u, okay, then multiply this by du over 3. So this is also 1/3 the integral of square root of u du. Now we can simply take the antiderivative of the square root of u, that is simply u raised to 1/2. So the antiderivative of this expression in terms of u would be something like 1/3 times u raised to 1/2 plus 1 divided by 1/2 plus 1 plus c. And in turn, this gives us something like 1/3 times u raised to 3/2. Then of course this one is multiplied to, since this is also 3/2, so that is 2/3. Okay, and then plus c. Now you can simplify this further into 2 over 9 u raised to 3/2 plus c. But then again, the answer here should be something like expressed in terms of x rather than u, kasi this one is just our substitution to the original equation, and we need to actually represent this in terms of the original variable. So in that case, that should be x. So with that being said, the derivative of, the equivalent of u is 2 over 9, and then that is 3x plus 2 raised to 3/2 and then plus c. So this is supposedly your final answer. Okay, so I hope that is a very clear process, or a very clear representation of what happened here. But if you want to directly, actually you can do something like direct integration to this, and you'll just be able to find the same answer by just simply using pattern recognition. If you let this inside function be your something like inside function your 3x plus 2, then the derivative is supposedly this 3dx. And this is what happens actually in pattern recognition. It's just that hindi na natin siya sinusulat kasi sometimes it's very recognizable, but in cases when it is really difficult to identify, then pwede natin siyang isulat like this one. Okay, so I hope klaro na tayo dito sa sa solution na to. So let's move forward naman sa other examples. Now for this example, what we have is square root of 2x minus 3, and then meron tayong x dito sa outside of our function inside the radical sign. So if you try to do pattern recognition here, you won't be able to recognize any pattern because as you can see, itong 2x minus 3, if you take the derivative of that, that will be 2dx, which is not exactly this one. And if you try to differentiate this one, of course, mas malayo yung sagot mo compared to this other function that you have. So this is where this change of variables come in handy. Now let's have u. So u is usually, this is equal to those algebraic expressions that are more than one term. Because if you just substitute this by x, then practically speaking, you just have to like substitute all these variables in terms of u, and you can't really modify the equation. So with this, try natin na gawin this one being the 2x minus 3 yung ating u. So that is 2x minus 3, and then if you want to differentiate this, so that will be du is equal to 2 du. Okay, and it makes sense when we have this dx that is equal to 1/2 du. Okay, now if you try to substitute this, and we actually need the value of x in this case, so from here the value of just x would be something like u plus 3, and then you just take the 1/2 of this u plus 3, and that is simply equal to x. Okay, it's just a matter of algebra. So knowing this, we can now represent this in terms of u, so that will be something like 1/2, and then u plus 3, and then you multiply this with the square root of u, okay, and then of course times 1/2 du. Okay, so you can now factor out yung ating mga constants here, so that will be 1/4 the integral of something like u plus 3, and then the square root of u du. Okay, now to solve for this one, we can actually expand this. Okay, so para mas madali natin siya ma-solve, so let's try expanding that. So that will be 1/4 the integral of something like square root of u times u. This becomes u raised to 3/2, that because we have 1/2 plus 1, and then the other one will be plus 3 square root of u. Okay, so that is du. Now you can actually integrate this directly using fitting integrand. So this becomes you perform the first operation first. So we have 1/4 then you multiply this with the derivative of the first term, so that will be u raised to 5/2. Okay, and then of course this is multiplied with 2/5, and then plus 3 times u raised to 3/2 times 2/3. Okay, so this is plus c. Then of course your answer would be something like, now I want to delete this so as to give us more space. So with this, our answer would be something like 1/4, something like u, I mean 1/4 times 2/5, and then u here is this 2x minus 3, so that becomes 2x minus 3, then raised to 5/2, and then of course plus 2/9. Hello students, I want to fix things out here because I had an error in calculation on that simplifying. So it should be 2 times 2x minus 3 raised to 3/2, because instead of multiplying to the denominator, it should be cancelled out. So yung 2 yung matitira, and then syempre yung final answer mababago siya, so the final answer should be something like 1/5 times 2x minus 3 raised to 3/2 multiplied to x minus 1 plus c. So that should be your final answer to that. Okay, so in this manner, if we try to have tangent 5x as our u, you'll be able to get secant squared for this derivative. So it's not really exactly the other one, but what if you try to have secant x as your derivative, I mean your u function. So if you try letting u equal to secant 5x, what you'll be getting here is your derivative, which is something like secant 5x tangent 5x, and then of course times 5 dx. So this is quite closer to the expression, because if we try to rewrite this in terms of u or du, then we can factor out something like secant from this expression, and then we can resolve for this in terms of u. So ano ba yung sinasabi ko? So diba, this term tangent 5x dx divided by 5 and then secant 5x, you can rewrite this in terms of something like du over 5. This is equal to secant 5x tangent 5x dx. Okay, and then if you have something like u squared, then this gives you the original expression. So this gives you the final expression in terms of u, which is u squared du over 5. Okay, so I hope this makes sense now. And if you try to rewrite this in terms of secant 5x, so that will be squared, and then multiplying it with du over 5, that becomes secant cube, and then we're left out with the same original expression. And now we can perform integration into this portion. So this gives you a value of 1/5. I'll just factor out the constant, and then yung u squared natin is power rule, so that gives you u cubed over 3, which gives you an answer of 1 over 15 u cubed, and then of course you have to add the constant of integration. So finally, rewriting it back to your original equation, our answer should be something like 1 over 15, and then of course secant of 5x, that this one is raised to its cube, and then you add the constant of integration. So this is supposedly your final answer. Okay, now if you want to check, so let's factor out 1 over 15 by differentiation. So let's have it here. So we have 1 over 15, and then using this as power rule, so we have 3 times secant squared 5x, and then the derivative of secant is actually secant 5x times tangent 5x, and of course times 5 dx. So this can cancel out the 15 in front of our expression. So now we're left out with secant cube 5x tangent 5x dx. Okay, so I think that's it for letter C. Now for this example, we have the integral of 3 cotangent, hyperbolic cotangent of 3x, and then the sine hyperbolic of 3x squared dx. Now, what would be our u function here? So pag tinry nyo i-differentiate ng cotangent hyperbolic 3x, so it will not result to this hyperbolic sine of 3x, and as well as this being differentiated will not result to this first expression. So what we have to do here is to redefine this by using some of the properties of our hyperbolic functions. So if we try to rearrange this in terms of cosine of h over 3x over sine h of 3x, we can actually cancel out some sine h here. So that will be 3, and then cosine hyperbolic of 3x divided by sine hyperbolic of 3x, which is actually cotangent of hyperbolic cotangent, multiplying this by the square of this hyperbolic sign. So this gives us the final expression will be something like 3, and then hyperbolic cosine of 3x, and then sine hyperbolic 3x, and then dx. Now, can we solve for something like letting u of any of the function here? So the answer is yes, because if you try to let u, so if you try to let u being this hyperbolic sine of 3x, then the derivative would be something like du is equal to hyperbolic cosine of 3x times 3, which gives our dx, and then this gives us a fairly the exact answer here, that is 3 hyperbolic cosine of 3x and then times dx here. So we can now rewrite this expression in terms of something like u and then of course du. So this gives us a final answer for the antiderivative of this expression in terms of u, that is of course u squared over 2 plus c. And yun substitution to our original expression, so itong u magiging something like hyperbolic sine of 3x squared, okay, and then divided by 2 plus c, and this is your final answer. So if you want to check that, you can see it clearly na you just have to do power rule. So makakancel out yung 2, matitira na lang is hyperbolic sine of 3x, and then if you try to differentiate that, you will be getting something like hyperbolic cosine of 3x times 3. Now you can rewrite that in terms of cotangent h, but make sure that you have to square the hyperbolic sine of 3x. That's why it results to the same property of this, or the same integral. Okay, so I hope it is clear in this case. So sometimes makaka-encounter kayo ng parang mahaba siya, pero at the end of the day, at the end of the solution, you'll see na sobrang simple niya lang. And that's the tricky part of integral calculus. Sometimes the problems look difficult, but when you try to evaluate it, sometimes it's really easy. But those expressions that really look easy, sometimes they're those that are really kind of difficult, and we have to employ a lot of things in order to solve those certain problems. Anyway, so let's proceed with the next one. Now for this one, let's have letter E. Now in cases like this where there is a composition of a binomial, and then of course a binomial raised to a cube and then square root inside a radical sign, it is always best to let u, or let the function u equal to those that are inside the radical sign. Although that's not always the case, it's a case-to-case basis, but most of the time it is a lot easier to let the functions inside the radical sign the u function. So with that being said, let's do it here. So our u, now for the next one, what we have here is x minus 3 multiplied with the x minus 1 cubed, and of course square root of that expression. So we do have these two binomials multiply with each other, and basically in fitting integrands and of course pattern recognition, we are not able to determine a rule that can directly integrate this. So what we have to do is to let the u substitution in this case. Now, what is the best pick in these cases where there are two binomials? Now, we usually use the u substitution for those expressions that are inside the radical sign, because it makes it a lot easier. So in this case, we'll be letting u equal to our 2x minus 1. Okay, and then from this, we can now find the value of x, because we'll be needing that. So from this expression, what we have here is x is equal to 1/2, that is u plus 1, because if you transpose 1 from here, then divided by 2, then you'll be getting this answer. Now let's have this derivative. So we have here du, that is equal to 2dx, and by this notion we know that dx is equal to 1/2 of du. Let us rewrite this expression in terms of u. So that is the integral of using this expression. So we have 1/2 u plus 1, so that is simply x, and then minus 3, okay, and then we multiply this by something like u cubed, because this is exactly your u, and then of course dx is times 1/2 du. Okay, so finally we can elaborate this further into 1/2 u plus 1/2 minus 3, okay, and then the square root of u cubed times 1/2 du. Okay, and I think we can also rewrite this in terms of something like 1/2 u and then minus 5/2, because 1/2 minus 3 is 5/2. Okay, because that is something like 2.5, because that's 0.5 minus 3. So this is probably the one step closer to the final expression. So I just rewrote this 1/2 in front of the integral sign, and we can now actually distribute this square root of u cubed para magkaroon tayo ng enough expression so that we can integrate it directly. So what we have here is 1/2, and then the integral of, so having 1/2 u multiplied with the square root of u raised to 3/2, so we'll be getting something like 1/2 u raised to something like 3/2 plus 1, which gives you 5/2, okay, and then of course minus 5/2 times u raised to, of course, 3/2, okay, and we can actually integrate this whole expression now. So integrating this, what we'll be getting is 1/2 times 1/2 u raised to 7/2 because this, if you add 1, this becomes 7 halves. And of course, you need to multiply this with the reciprocal or divide it by 7 halves itself. So that becomes something like 2 over 7. And then finally, for this one, we have minus 5 halves, u raised to 5 halves, and then you multiply this with 2 fifths. Okay, and then you add the constant of integration. Now we can cancel things out here. From this, we can cancel out 2, and from this expression, we can cancel out the whole thing here. So this leaves out with 1 over 7 u raised to 7 halves minus u raised to 5 halves plus c. Okay, and we can also factor u raised to 5 halves here. So what we'll be getting is this expression. Let me just delete this. Okay, so hopefully it will not mess up our solution. So what we'll be getting is something like 1/2 times u raised to 5 halves, okay, and then 1 over 7 u, because that is 7 halves. If you subtract 5 halves, that you'll be left out with u, and then minus, because we have u raised to 5 halves here, and then we factor that out, so we'll be left out with 1, okay, and then plus c. Okay, so this is the final expression for your answer in terms of u. Now if you want to have it in terms of x, so let's just substitute the values. So we have 1/2 times u, that is 2x minus 1 raised to 5 halves, then multiplied with 1 over 7, and then 2x minus 1 minus 1 plus c. Now this can be further simplified in a way that we can just perform the operation inside this bracket. So let's have it 1/2 2x minus 1 raised to 5 halves, then multiplied with 1 over 7 times 2x. This becomes something like 2 over 7x minus 1 over 7 minus 1. Now if you try to subtract 1 over 7, actually that will be adding this 1 over 7, so that becomes negative 8 over 7. I used my calculator to make it sure, so we add c here. And then we can now simplify it further, because as you can see from the inside expression of this bracket, we can factor out positive 2 over 7 here just to clear things out on the inside the bracket. So I'll be taking out 2 over 7, okay, which will give me the simplified version of the inside of the bracket, which is x minus 4. Okay, so I hope it was clear to everyone. Because I factor out 2 over 7 here, the thing that will be left out for 8 over 7 will be positive 4 only. Negative 4. And then you add c. And we can cancel out 2 here, so that will leave us our final answer in the simplified form, that is 1 over 7 and then 2x minus 1 raised to 5 halves multiplied with x minus 4 plus c. Okay, so hopefully I think this is very easy. It's just that I think you're getting kind of confused with the simplifying, but I'm fine with this kind of answer, as well as this. No, not the u one, but the one that is really not that simplified, but you've already substituted the values of x in terms of, you already substituted the values of x from the u substitution. So I'm actually fine with that. Okay, so I hope you understood this item. Now let's move forward to the next one. So for this expression, what do you think would be our u, and what do you think would be our our u? So you might be saying that since I said actually that those that are inside the radical sign would be the best one to have it substituted in terms of u, then you might be thinking that that should be the one here. So if we do that, let's try, just to show you, let's try doing that, and you'll understand why is it sometimes the best choice. So if you let me use another color. So if we have u equal to square root, u equal to x minus 5, we'll be getting something like du, which is equal to dx, and then of course x would be equal to u plus 5. Okay, now upon substitution to our original equation, what we have would be something like u plus 5 minus 4 okay, and then the square root of u, and then divided by something like u plus 5 minus 8, and then du. So this further simplifies into u plus 1 square root of u, and then divided by u minus 3 du. Now, can you actually simplify this further? Can you integrate this in a way that it has a fitting integrand? Now, if we try distributing this square root of u in the numerator, we can do something like the integral of u raised to 3 halves, okay, plus u raised to 1 half divided by u minus 3 du. Okay, so um, knowing this final expression, we can actually dissect this, okay, and then we can perform this u raised to 3 halves and then u minus 3 du in a way that knowing this is 1.5 degree, that's 1.5, that is greater than 1 because this is actually 1. So this rational expression can be integrated using long division. But how about this something like plus the integral of u raised to 1 half over u minus 3 du? We know very well that this doesn't actually conform with any rule in the fitting integrand. So in cases like this, you have to apply another u substitution. And for such cases, that will be a lot difficult for us to solve for such kind of problem because it takes two u substitutions. So what we have to do here is to find another u substitution that is most appropriate for this problem. And I want to tell you that if the composition of the integrand is like this, okay, it is composed of one of the integral symbol and then a rational expression wherein each of them are the same degree, then the easiest one to let u would be the whole radical expression. So that will be u is equal to the square root of x minus 5. Okay, and you'll see it later why is it the best choice. So we have du that is equal to 1 half, okay, and then x minus 5 raised to negative 1 half dx. Okay, and from this expression we need to find actually our x value. So x would be equal to u squared plus 5. I hope you get the idea that if you square this u and then we add 5, then that would be our x. Okay, and from this expression, this is the tricky part here. If you want to simplify dx would be something like 2 2 multiplied by x minus 5 raised to 1 half. Okay, and of course that will be du. So this is your expression in terms of du, but it still has this x and we just need this dx. So we need to represent this x minus 5 square root in terms of u, so that becomes 2u du. Okay, so this is a lot cleaner now. Okay, so we can now substitute these values in terms of u, so that becomes the integral of x minus 4, that becomes u squared plus 5 minus 4, and then the integral of multiplied with u itself, and then dx would be something like 2u du. Okay, and then we divide this by u squared plus 5 minus 8. Okay, and then we can simplify this 5 minus 4 in terms of positive 1 because that is 5 minus 4, and then this 5 minus 8 we can simplify this in terms of negative 3. So this becomes u squared minus 3. Okay, so this is your final expression for your integrand in terms of u. Now we can actually perform distribution or multiplication here at the numerator. So this becomes the integral of u squared times u becomes u cubed times 2u, so that becomes 2u to the fourth. Okay, and then plus we have 2u squared. Okay, and then we divide this by u squared minus 3, or we can just simply factor out 2 from this expression, so that becomes 2, and then we have something like u to the fourth plus u squared divided by u squared minus 3. Okay, now this would have been a lot easier if this is factorable, or we can redefine this in terms of factor and then we can remove some of the factors right away. But because this is not factorable and this is a rational expression, what we have to do here is, remember I've told you something about the numerator having a degree that is greater than the denominator. So what we have to do here is to perform long division. So we'll be doing that in this case. Now the difference doing long division in this case than the previous one is that you'll be performing long division here once, other than substitution. Unlike the substitution a while ago, wherein you have to perform long division and then another u substitution, in which after substitution you're still not quite sure if you'll be able to integrate it directly. Okay, so ngayon I'll try to perform long division from, I think it's here. So that is u to the fourth plus u squared divided by u squared minus 3. Okay, so we have u squared, okay, and then u squared minus 3u squared, subtract. Okay, so I think we have positive 4u squared right away, so that becomes 4u squared, okay, and then plus 4, okay, and then that will become 4u squared minus 12. Okay, so subtracting this we get positive 12. Okay, so our final answer would be something like u squared plus 4, u squared plus 4, and then plus 12 over u squared minus 3. So, and now that we already have this final form of the integrand that we need to integrate in terms of u, so we can actually do integration right now. So I'll just be removing these things that I don't need anymore. Okay, so I think this can be removed. Okay, and finally let's integrate. So the first term would be something like 2 times, of course, u squared would be u cubed over 3, and then of course this second term would be 4u, okay, and then finally this term, what could probably be the function that can integrate this directly? So if you'd be looking at the rules, I'll be using the one that is in terms of inverse hyperbolic tangent. We know quite well that if you have plus or minus 1 over something like a squared minus x squared, the integral of that in terms of dx, this is equal to 1 over a and then the inverse hyperbolic tangent of x over a. So why is it possible that we can use this even though a squared comes first before x squared? Now if you look closely, I can rewrite this 12 over u squared minus 3 in terms of negative 12 over 3 minus u squared, which makes perfect sense because if you try to redefine this in terms of this expression, I'm just not actually changing the last term, so I'm just making this look like this expression wherein there's not really that I'm not really changing the expression. So yun, ganun lang siya gagawin nyo. Once na maka-encounter kayo ng ganitong denominator and then may constant sa taas, usually we can use the inverse tangent hyperbolic inverse tangent. So pwede nyo siyang gamitin, just rearrange the denominator and the rest of the expression and just make sure that you will arrive at the same expression as before if you try to evaluate that. So with that being said, I can now perform the integration of the last term, so that becomes negative 12 times 1 over a, so that is 1 over the square root of 3, and then of course that becomes the inverse hyperbolic tangent of x over a. In this case, that is u, so that is u over the square root of 3, and then finally we close the bracket and then we add the constant of integration. So finally this is our expression in terms of course of u, and we need to transfer it back to the original variable, which is x. So it's fairly easy, you just have to incorporate the square root of x minus 5. So with that being said, we have 2 and then u cubed over 3, so that becomes actually something like x minus 5 raised to 3 halves, because we know that this u is square root, so that becomes 3 plus 4 times x minus 5 raised to 1 half, okay, And then of course minus 12 square root of 3 inverse tangent of u, which is square root of x minus 5 divided by square root of 3 plus c. So this is your final expression for your answer in this problem. Now you can always factor out x minus 5 here for simplifying further. So let me just do that. So I can take out x minus 5 in this expression. So that is x minus 5 raised to 1 half. And then I'll be left out with, I think I'll be left out with one third um, x minus 5. Okay. So I'll be left out with one third x minus 5 and then um, 4 here because this becomes 1, and then minus 12 square root of 3, and then inverse tangent of square root of x minus 5 and then square root of 3 plus c. And then this is actually multiplied to all the terms. Okay, so this can be your final answer, but if you still want to further evaluate this, we can factor out 3 here in this expression. So this can simplify further in terms of 2/3, I think, x minus 5, and then um, the preceding answers. But I'm fine with this final answer in such case. So I think that's it for this answer, and I hope that you understood how this process worked. It's just a matter of um, finding the fitting integrand after redefining. Okay, so let's move on to the next problem. Now for our next problem, what we have here is the integral of x plus 2 divided by x plus 1 quantity squared dx. Now for such cases, when we encounter this form, what we have to do is to let u equal to the denominator. So kung mapapansin nyo kasi yung ating denominator, it is raised to a certain power, yung whole exponent, yung whole expression. So we can utilize the fact that we let u be our denominator. So that in turn, if you substitute this u to the original equation, then we'll be left out with a single term at the denominator. So we can now proceed with differentiation. So this becomes du equal to dx. Okay, and then if you want to find x from this expression, what we have here is x is equal to u minus 1. Okay, now if we try to substitute all of these to the original equation, then we'll have the integral of I think that would be u minus 1 plus 2 divided by u squared, and then of course du. And then if we rewrite this further, we have u plus 1 divided by u squared du. And this can now be rewritten in terms of the integral of, I'll be separating these two denominators, so numerators. So I have something like 1 over u plus 1 over u squared, and of course that will be du. Okay, so imagine having this line. So for the first one, you have u over u squared, which is 1 over u, and then the second one will be 1 over u squared. And now this can be integrated in a sense that they are already the fitting integrand that we know. So we can now integrate this. What we have here is du over u, so this becomes the natural logarithm of u. So that will be ln of u, and then plus this one is u raised to negative 2, so this becomes u raised to negative 2 plus 1 divided by negative 2 plus 1 plus c. So the final answer in terms of u would be the natural logarithm of u, minus u raised to negative 1, then of course plus c. Now upon substitution with the value of x of u, so this becomes the natural logarithm of x plus 1 minus you can use x plus 1 raised to negative 1 plus c, or you can rewrite this in terms of natural logarithm ln of x plus 1 minus 1 over x plus 1 plus c. So this is your final answer. Now for our now for letter H, what we have here is the integral of 1 over x plus x ln of x. And what we have here is that it is not a fading integrand because you can actually find any rule that can directly integrate this. So what we'll do here is that we'll factor out x at the denominator because it's factorable, and you will notice that we'll be able to find a certain derivative of a certain function. So if that's the case, then this is equal to the integral of, let's just use dx here, dx over x times 1 plus ln of x. Okay, and if you let u equal to the natural logarithm of x, we could therefore say that the derivative is simply equal to 1 over x dx, or simply dx over x, and this is exactly that derivative. Okay, so if we want to rewrite this in terms of u, then the expression would become the integral of du divided by 1 plus u. Okay, so this makes perfect sense because dx over x is simply du, and then 1 plus u would be this 1 plus the natural logarithm of x. And now we can directly integrate this by our idea of integration. So this is the extended form of the natural logarithm expression. So therefore, the antiderivative of this expression is the extended rule for our natural logarithm. So this becomes uh, the natural logarithm of 1 plus u and then plus c. And if you want to substitute this u in terms of ln of x, then this becomes the natural logarithm of 1 plus the natural logarithm of x and then plus c. Okay, so this is your final answer for this problem. Okay, and then I think we're down to the last item, so let's have it here. Now, if you'd be looking at our integrand, you would say that this is not a fitting integrand nor pattern recognition because you can't see an exact fitting integrand for this or any rule that will satisfy this expression. But if you would look closely at this tangent inverse of x, if you would be differentiating that, you'll be able to get this 1 plus x squared dx. So we let this equal to u, so that becomes the inverse tangent of x, and then you take the derivative of this expression, so that is du equal to 1 over 1 plus x squared dx, which makes perfect sense in this problem. So we can now plug in our u values here, u variables. So that is the integral of e raised to m times u, and then we multiply this with du because that is the exact expression of dx over 1 plus x squared. And by looking at this form, we can easily integrate it by fitting integrand. So in this case, we have e raised to m times u, because we already know that if we have this exponential function, we just have to copy it and multiply it with the inverse operation of what is incorporated in your variable. So in this case, that is multiplied by m, so we have to divide this by m. Okay, and then we add the constant of integration. So this is your answer in terms of u. Now we have to we have to substitute this in terms of x. So we have e raised to m times tangent inverse of x, and then divided by m plus c. So this is your final answer for this problem. Okay, so I hope you've understood clearer this change of variables and pattern recognition, and it's always these methods that give birth to more complicated topics in integral calculus. And I want you to always practice noticing things, especially the expressions that can be integrated directly, because that is the only way that we can deal with this problem, especially when we have those fitting integrands and we need to redefine them first before we're able to solve for it. Tsaka, yung kasing mga problems natin dito na na-encounter, uh, ito lang yung parang mga problems na madali mo siyang makita kasi basic integration procedures pa lang siya. So if ever we'll be encountering problems that are more complicated, then we need to apply this concept of basic integration procedures just to solve for problems that are actually much harder. So I think the next video will be about other techniques that we can apply for this preliminary discussion. So I'll see you on the next video.